Let's begin. Today is August 22nd, 2024, and we're solving the Daily Turing Machine Puzzle. Today's puzzle uses the following 5 criteria cards. Criteria card 7, 9, 14, 18, and 21. And the puzzle uses the green verification cards. The code above is your way to get more information on today's puzzle by searching the code on turingmachine.info. Let's go solve. So in the grid above, we've got our 5 criteria cards. On the top row, we've got criteria card A, criteria card B, and criteria card C. On the bottom row, we've got criteria card D and criteria card E. So criteria card A looks at our last digit, the circle digit, and will let us know whether its value is even or odd. Criteria card B will look at the 3-digit solution and will let us know how many of those digits are 3. Are there no 3s? Is there a single 3? Perhaps 2? Maybe even all 3 are 3. Criteria card C will look at our 3 digits, triangle, square, and circle, and will let us know which one is the absolute smallest. So should triangle be the smallest? Should square be the smallest? Or should circle be the smallest? Next, criteria card D again looks at our 3 digits, triangle, square, and circle, but this time it'll add the 3 digits, and the Turing Machine will let us know whether the sum is an even quantity or an odd quantity. And finally, criteria card E will look at the 3-digit solution and will let us know a little bit about its structure, so to speak. Specifically, one case is that there could be a pair, as in the example 131, or alternatively, there are no pairs, but there are a couple of scenarios. One where all the digits are different, as in the example 134, or all the digits are the same, as in the example 222. And remember, the objective of today's puzzle is to find that one unique 3-digit code that abides by the 5 criteria cards we just discussed. And we're going to start off with an initial proposal of 314. So the first thing I want to do is I want to find out a little bit about that last digit. So let's go ahead and test criteria card A. Okay, so the Turing Machine does not approve of what I chose for my last circle digit. I did choose an even 4. Since it disapproves, it's basically letting me know that circle should be odd. So let's go ahead and type that up in our notes. In section A, we'll say that circle is an odd digit. And of course, since it is odd, that means we can cross out both of the evens. So we can cross out 2 and 4. The next thing I want to find out is the sum total and what it could be, whether even or odd. So let's go ahead and test criteria card D. Okay, so again, it disapproves of what I chose for my initial proposal. We are adding them all up. So let's go ahead and add up 3 and 1. That gives us 4. 4 plus 4 is 8. The sum total of my proposal is 8, an even 8, but the Turing Machine does not approve of that. So it's letting me know that no, the sum total should actually be odd. So let's go ahead and type that up in our notes for section D. And that again is that triangle plus square plus circle should be an odd quantity. And because the sum total needs to be odd, let's go back and look at what we discovered when we tested criteria card A. We know that circle is already odd. So that means if we want the sum total to remain odd, there are a couple of scenarios. Either both triangle and square are even, or both triangle and square are odd. So it may be obvious that if all of them are odd, yeah, the sum is going to be odd. But in the case where they're both even, well, when you add two evens, you get a total of even, but you want to add that last digit to at being odd so that the sum total remains odd. So again, we're looking at a potential solution of either two evens or all odd. Two evens and an odd or all odd. Okay? And but we don't know what that might be. So let's go ahead and test criteria card E. Oops. Okay, so in this case, the Turing Machine does approve of my proposal. Notice that I do have all distinct digits. So that is the case where there are no pairs. That's a 314 is a case of having no pairs, and the Turing Machine approves of that. So let's type that up in the notes for section E, and we'll say that the solution has no pairs. Now remember, we do have two possibilities. They're either all different or all the same. The reason it can't be the second case where it's a single digit repeated 3 times, like 222, is notice that we do have criteria card C that we didn't get to test, but there's an absolute smallest. So obviously if you have the same digit repeated 3 times, there is no absolute largest. And so you do need one. So let's go ahead and remove that from being a possibility, and so all the digits are distinct. Okay, well, that does it for this round. We did complete our 3 Turing tests. We're now going into the phase where we'll be discussing how to construct a good second round proposal. So notice that we did not test criteria card B, the quantity of 3s in our solution. Well, since we know that the solution has to be all distinct, it'll be interesting when we test, and possibly, we kind of ran out of time or options for round 1, but this will be interesting. If there is no 3, then I think we can we conclude that it may be, let's see, if there is no 3, I think if there is no 3, it'll be interesting. I think that implies that you have to have 2 evens and an odd. Because again, if you have the case of either 3 odds or 2 evens and an odd, if there is no 3, and say you have 1 and 5, right, the other 2 odds, and they are all distinct, if you add an even into the mix, that sum total is actually even. So the absence of a 3, oddly enough, implies that the other 2 digits are even. So that might be a good, way to set up our second round proposal. Maybe not including 3. And then, of course, we did not test criteria card C, the absolute smallest. But I think everything else, we can definitely apply towards our second round. So let's go ahead and see if there is no 3, and that's what I think that's how I'm going to create my second round proposal. I'm going to remove the 3, not include it, and so I'm thinking circle because it's going to be the smallest. I'm going to choose, I think, 1 for circle. Well, let's see. Oh, this is interesting. How would I construct? How would I choose, say, my 2 evens among triangle and square? Oh, so no, I take that back. Perhaps it won't be circle being 1. It may actually be a 5. because if it's a 1, yeah, there's no way I can, that has to be the smallest. I don't have any other indication on how to pick my two evens among triangle and square. There's no way to order them. So let's see, what if circle is 5? Yeah, I think that's what's going to be. Circle will be 5, and then the 2 among the 2 and 4 will be the smallest, and that'll be either triangle or square, and then obviously the other number will be a 4. So it's going to be sort of a 50-50. It's either going to be 2, 4, 5 or 4, 2, 5. And so I'm going to choose 2, 4, 5. So let's go ahead and try that out. Okay, so let's see. If I choose, or if I choose to test criteria card C first to see which one's the smallest, will I be able to deduce that there are no 3s? Well, let me go ahead and test criteria card C first. Okay, so it is true. If I look at my proposal, my triangle value of 2 is the smaller of the 3, so the Turing machine does confirm that. So let's go ahead and type that up in section C, that triangle is the smallest. So triangle, let's see, I'll just type it up as is the smallest. Okay, and since it is the smallest, I think we can eliminate 5 for triangle, because if triangle is 5 and it's the smallest, there's nothing else for square and circle to be, so it can't be that. And I think we can also eliminate square 1 and circle 1, because if triangle is the smallest and either square or circle are 1, there's nothing for triangle to be smaller than 1. So I think it's fair to say that, yeah, we can cross out 1 for square and 1 for circle. Okay, and so that would leave us with circle being 3 or 5. Can we make any other conclusions? If circle is small, yeah, I guess, if triangle is 4, yeah, I guess potentially square and circle could be 5. Although you can't have pairs. Well, that's interesting. So let's talk about that. If triangle is 4, I don't think you can say triangle could be 4, because the only options, and it is smaller, that would imply that square and circle have to be 5s, but we know they have to be distinct. So I think you can also eliminate 4 for triangle. Now, I think 3 is okay, because now you can distinguish square and circle. It would be 3, 4, 5 as a potential solution. And anything else? What about 2? Square is 2. So square is 2, triangle is 1, and yeah, you got plenty to pick from among 3 or 5 for circle. So yeah, I think that's the only thing you can do or cross out at this point. And so let's go ahead and test criteria card B and see if there is a 3 or there isn't. Because at this point, yeah, we still, they could all be odd, I guess. But let's go ahead and test criteria card B. Okay, so it approves that there are no 3s in the solution. So yeah, so let's go ahead and type that up. And so we'll just say there is no 3-digit in the solution. And so that means that yes, we can cross out all of the 3's. So we'll cross it out for triangle. We'll cross it out for square. And we'll also cross it out for circle. So very interesting. Yeah, so circle is 5. Okay. And even just by looking at this, we know it can't be an all odd solution because square, the only other odd that there is 5, and you can't have duplicates. So I'm not sure. I haven't really reconciled how the triangle and square are circle just yet, but it does seem, based on what we have left over, that it cannot be an all odd solution. So let me think through some of this stuff. So we know that, let's see, so we know square can't be 5. There we go. So square can't be 5 because then what would circle be? They're supposed to be all distinct. So at this point, we go back and say, well, yeah, square can't be 5. And so now square we've established to be even, and so then that means that the overall sum, well, we have an even for square and an odd for circle. That sum is odd, but to remain odd, you need to pick triangle to be square. And so, triangle to be even, and of course the only available even is 2. So yeah, so we can cross out the 1, and so triangle is the smallest at 2. No duplicates, so square can't be 2. So that means it's 4, and then circle is already 5. So yeah, so that's our solution, 2, 4, 5. Okay, and I think, yeah, everything we tested, what kind of is confirmed. Yeah, circle is, or the last digit is odd. It is. There is no 3. That's correct. Triangle is the smallest. The overall sum is odd. That is true. And they're all distinct, no duplicates. So looks like we've got a winner, but let's of course confirm its validity. So let's go check. And so let's type up 2, 4, 5. And let's see. Fantastic. Okay, so let's actually confirm how we did versus a Turing machine. So I believe, yeah, we only tested 5 criteria cards, and that's always a good indication that at least we tied or beat the Turing machine when the number of tests equal the number of criteria cards. So we did test in the first round A, D, E, and the first 2 were incorrect, and then E was correct, and then the remaining 2 criteria cards were correct in the second round. So let's type that up again. First round was A, D, E. So A was incorrect, D was incorrect, E is correct, and then second round were the remaining 2, and they were both correct. Okay, fantastic. So we beat it by 1 question. Okay, so yeah, looking back, I think our choices in the first round really helped us out. And I will say that, as you do more and more puzzles, you sort of see certain patterns or certain scenarios. Now, it doesn't always play out that way because, conditions or responses from the Turing machine, can give you a twist, or zig or zag, so to speak. And so sometimes it helps out, but like I said, certain previous puzzles sort of tend to lean you as a solver in a certain way, and that's how I was able to basically get 245 to be correct as my second round proposal. Well, if you have any questions or comments, add them to the comment section. Give it a thumbs up if you like the video, and of course, don't miss out on any future videos. Hit subscribe. Well, until next time, have a great one.